Okay, the first thing that we need to do is we need to remember that 1 over sine of x is equal to cosecant of x. They are reciprocals. Okay? They are reciprocals. One over the sine of x is equal to cosecant of x. CSC. Now, here's something important for you to remember. This has to sink in your brain. What is 0 over 1? 0. Now, if you take the reciprocal of 0 over 1, you get 1 over 0, which is undefined. So you need to remember that 0 and undefined are reciprocals of one another. So what happens then is for sine, wherever it's equal to 0, that's where cosecant is undefined. Okay? That's where cosecant is undefined. So let's think about this. If we were to sketch a little graph of sine, do you remember what the maximum value of sine is? Oh, come on, folks, we know this. Maximum value of sine? Amplitude, its highest spot? 1. What's its lowest spot? -1. What's the period? 2 pi over b, so 2 pi, right? And we divide it up into how many spots? 4. I'm not going to label them so that I have room on my graph to sketch it. But does sine start at the max, min, or middle? Middle. So as you sketch the graph, like so, can you see where sine is equal to 0, where it crosses the x-axis? Somebody give me one value where sine is crosses the x-axis. 0 would be 1. Give me another one. Pi, 2 pi, -2 pi, -pi, values like that, right? So if sine is equal to 0 at those spots, then that means that cosecant is undefined because the reciprocal of sine is cosecant and the reciprocal of 0 is undefined. So cosecant is undefined for things like -2 pi, -pi, 0, pi, and 2 pi. What kind of shape do you think we draw if it is undefined? What did we learn yesterday? What is that called? A vertical asymptote. Asymptote. Yep, very good. All right, so we're going to graph cosecant now. And here's how you graph it. We start by doing the same things we did before, which is identifying its period and its amplitude and all those other things, okay? But we treat it like it's y equals sine of x. And I'll show you what we do. This is going to look confusing, but as long as you know how to graph sine, trust me, you'll be able to do this. What is the amplitude of sine? 1. What is the period? 2 pi. So just like we did before, I'm going to sketch sine, but I sketch it as a ghost graph because I'm going to use the graph of sine to come up with the graph of cosecant. So I'm going to go up to 1 and down to -1. And no, I didn't use the whole region there to sketch 1 and -1, and you'll see why. Yep, I would put it in the middle, and you'll see why in a second. Then we divide it up into 4 spots. And just like every other day, we always learn something new. It's trigonometry is definitely not review. It's definitely not review. Okay, so I've marked my amplitude and I've also marked my period. Tell me, where does sine start? Right at the middle, right at 0. Very good. And then am I going to start by going up or by going down? where is the graph equal to 0? You tell me when to stop, and I'll put a dot there. Can you get the idea? Those are the spots where it's equal to 0. So if that's where sine is equal to 0, then that is where cosecant is. So what shape am I going to have there? Wherever it crosses over there, you draw a vertical asymptote through there. Okay, then this is the last time I'm going to have you think really tough through something, okay? But right here, right at this spot, what's the height of the sine function there? How high is it? What is the reciprocal of 1? 1, right? If you take 1 over 1 and you take the reciprocal of it, you get 1 over 1. So cosecant has a height of 1 there. But watch this, okay? Look at this spot right here. Is this a really big value or a really small value? So let's say it's a really small value, say 1 over 100. What's the reciprocal of 1 over 100? So the reciprocal of a really small value is going to be a really big value. So it's way up there. Look at right here. Really small value or really big value? Really small. So when you take the reciprocal, you'll get a really big value. So these red shapes are actually what the graph of cosecant looks like. We put dots on the spots where it has minimums and maximums, and then we draw these curves that follow along the vertical asymptotes. So you can see that the green graph is sine. Once we graph sine, all we have to do is draw our asymptotes and then draw those U-shapes. Now that took a little while to get through, but trust me, when we do a couple more, you'll be like, oh wow, that really wasn't bad at all. Like the next one, secant. Instead of graphing secant, what's the reciprocal of secant? Cosine. What's the amplitude of cosine of x? 1. What's the period? So I'm going to mark out 1 and -1. 2 pi, I'll divide up into 4 parts on each side. Sorry, those are positive. Does cosine start at the max, min, or at 0? It starts at the max in this situation. And then it will go down from there. So I'm sketching this ghost graph. It isn't the actual graph. But this ghost graph is going to help me actually sketch what the real graph looks like. Now, none of that's my graph. But I want to mark where cosine is equal to 0. So I mark all the spots where it's equal to 0. And what do I draw through those spots? The vertical asymptotes. Yep, these are like vertical ghost lines. Exactly. Okay. Technical name, vertical asymptote. And then at the max and mins, I draw those U shapes. I got a spot right here, U shape. So which color is the actual shape of the graph? The red. If I were to graph this on my calculator, I would get that red spot. I wouldn't get the green. I'd get the red. That's the actual graph. So people ask, well, why do I have to sketch the rest? Because that's how we generate the graph. So that's why we sketch it, dashed. So, all right, so let's practice a couple, and then we'll have a short assignment for you, okay? We're not even going to do these, okay? We're just going to do three examples, okay? And that's going to be it. I'm just going to give you 4 homework problems. That's it. Okay? Just like I don't mind giving you a short amount as long as we do them, but we got to do them right away, folks. Okay. So y is equal to, I'm going to start by graphing 2 sine of x. What's the amplitude? Amplitude is 2. What's the period? 2 pi. So I mark off 2 and negative 2. I'm sorry you guys asked about the extra credit. I thought that Kelly just wrote down the decimal. She actually wrote them down both. So we did have one person get the extra credit. So nice job, Kelly. Before we move any further, is there any question how I came up with that? Because if I put them way up here, then the graphs would be off the page, wouldn't they? Yep, so good question. Question, Hannah. Because instead of graphing cosecant, I graph the reciprocal. I graph sine. And then after that, I'll be able to graph 2 cosecant. Because in green, I'll sketch the sine graph, but in red, I'll sketch that graph. Okay? Does that make sense? Start max, min, or middle? Middle. Up or down? Up. Now what? What do we call them? I mark all the zeros. That's where I draw my vertical asymptotes. Okay, now what? Make your U shapes at the top and the bottom of the mins and the maxes. Hey, guys, look at that. Does that look? I mean, knowing nothing about it, okay? If I would have shown you that right when we walked in the door, would you say that looks complicated or super easy? It looks really complicated, but was it really that bad? No. Isn't that cool? I mean, that looks like a very complex graph, but really, it wasn't that much work for us to do it. Let's do the next one. So for the next one, should I graph cosine or should I graph sine? I graph cosine because I need to do the reciprocal. And the reciprocal of secant is cosine. So what's the amplitude? Period. Is 2 pi over b. Pi. 2 pi divided by 2 is pi. Good. You remember when it was challenging for us to divide it up into 4 sections? And now that's something that we're getting better, right? Getting better at. Okay, my amplitude is 3. This is going to start with max, min, or middle. Y. Because it's -3. Cosine starts at the max or the min because it's negative is start at the minimum. And is it going to start by going up or going down? It's going to start by going up, right? Because you can't go anywhere else. You're already at the bottom. You got to go up, right? Rock bottom. What did I do? Did I reference the song or what? All right. Yes. Fast. Slow down, right? Okay. Now what? What not Mitzi, you're saying it. What is it called? Say it. Own it. Vertical asymptote. Everybody say it together on 3. 1, 2, 3. Asymptote. Yeah. All right. There we go. Through the middle. No, Hannah, you're disrupting my learners. Isa is trying to focus. She feels bad that her learning is being infringed upon. Should we should we have survivor class? Somebody gets voted off every day? All right. All right. Here we go. All right. So I drew my vertical asymptotes. Now I have to draw my U shapes. RT. Nadia says no way. A preacher. Um, yes, I've actually seminary. Not yet, but there's that chance someday. Okay, thank you. I appreciate that. Okay, last one. Yep. Okay, now we're going to do y equals -2 secant of 4x plus 1. What's different about this one? There's a vertical shift. Thank you. How do I know it's vertical? Because it's on the outside. Outside is vertical, inside is horizontal. Is there a horizontal shift? No. Folks, folks, for secant and cosecant, okay, we haven't done an example of a horizontal shift, but it follows just the same as sine and cosine. Okay? Folks, it's your work time. I've already done the problems. Okay? So, vertical shift is, well, first of all, instead of graphing secant, what do we graph? -2 cosine of 4x plus 1. That's what we want to graph. Once we sketch that graph, we'll be able to make our graph. So, I start with the vertical shift. What's the vertical shift? 1. What's the amplitude? So, if the vertical shift is 1 and the amplitude is 2, what's the highest spot it will go to? 3. What's the lowest spot it will go to if it goes 2 down from that? -1. Yep, some people definitely made that mistake on their test. I need to draw my horizontal axis. What's the period? I take 2 pi divided by 4, and I get pi over 2. Now, I'm going to divide this up. I'm not going to use the entire space. It's a little bit too much. What's half of pi over 2? Pi over, what's a half of pi over 4? Pi over 8. Now I'll count. 1 pi over 8, 2 pi over 8, 3 pi over 8. Then I'll go back the other direction. Where do I start this? Do I start at -1, +1, or +3? -1. Why? Because it's cosine, so cosine starts the maximum or the minimum. Because it's negative, it's going to start the minimum here. Then I go up, continuing to just make that ghost graph. Now here's the difference, folks. You don't mark where it crosses 0. You mark where it crosses your axis of rotation. So before I always rotated up and down the x-axis, right? This one's rotating on x equals 1. So those are the spots that we mark. So I mark this spot right here, this one, this one, and this one. I guess if you want to put one over there, you can kind of see it's going to. And then, what's my last step? Draw the U-shapes at the max and the mins. I'm going to give you guys your assignment and press pause on the video, and then I'm going to actually plug this into my calculator so you can see that this is the actual graph that we get, which I think is pretty cool that we can sketch something that complicated. So, all right, pause. Okay, please look real quick. First of all, that's your assignment. Second of all, I plugged in the function. Whoop. So you guys tell me if that looks like it or not. Does that look like this graph right here? There you go. You can for your assignment, but not the test. Sorry. You can use your calculator for computation, but I can't have you. I've had times in the past where people have graphed it. They've just taken the graph on their calculator and put it right on the test. And that's not what we want to do. So there you go.